Hello friends, welcome to another video of Zeta Axis, and today we are going to discuss yet another topic of GC Leong. Today we will discuss the cool temperate eastern margin system, or also called as Laurentian climate system. Now in the name itself we can see that it says temperate eastern margin, which means that this climate is in temperate region and on the eastern margins of the continent. The Laurentian climate is an intermediate climate between British and Siberian climate. We can see this blue color indicates the British climate in all these continents. And here this blue color indicates the Siberian climate, while this purple color indicates the Laurentian climate. Now when we say that it is an intermediate climate between British and Siberian climate, we do not mean that the region lies between these two climates, but what we mean is the precipitation and temperature characteristics is what is in between the British and Siberian type of climate. Now there is another interesting feature of Laurentian climate, that it has effects of both maritime, that is the oceans, as well as continentality, that is distance from the ocean. So we can see that in some regions there will be effect of oceans which will reduce the temperature, while there will be other regions which are far from the oceans where we will see extremes of climate. Now there are only two regions in the world which experiences this type of climate. The first is in North America. It can be seen in Canada as well as USA. In Eastern Canada, specifically in maritime provinces, which are the states of Canada in this region, as well as Newfoundland. And Northeast US provinces, that is New England provinces, which are also located in this region. And in the Asian continent, we can see eastern coastline of Asia experiences this Laurentian climate. We see it in eastern Siberia, that is part of Russia. Then we have North China, Manchuria, Korea, and northern Japan. So we can see even northern Japan has this type of climate. Now here we can see the rain and temperature characteristics of three important cities in this region. The first is in New York in USA, where we can see there is uniform rainfall because of the maritime effect. The temperature range is also slightly less compared to Beijing. Here we can see the effect of continentality. The temperature margins are extreme and the rainfall is concentrated. And if we come to Japan, Tokyo, which is an island, then we will see that the temperature range is reduced a lot because of the ocean surrounding the Japan, and we also see that the rainfall is almost distributed across the year. Therefore, we can see the maritime effect over here, continentality effect of here, and a mixture of both over here. Now, if we see in southern hemisphere, we do not see any region experiencing Laurentian climate. And the reason is that there is very little landmass south of 40° south latitude. So we can see that even in Australia and Africa, there are no landmass which are south of 40° south. So only South America has the conditions or the region which could have experienced Laurentian climate. Patagonia Desert is a region where there should be a Laurentian climate because of the presence of Andes, which blocks the winds coming from the Pacific Ocean. Remember, this is the westerlies region. Wind will be blowing from the Pacific towards the South American continent. Now, because of the Andes, the winds are not able to reach over here. And this region experiences extreme aridity, that is desert-like conditions. If Andes were not there, the winds would come and they would give less rainfall, but it would be not having the effect of aridity. But because of these Andes mountains, we see that winds are not able to reach here, and it gives an extreme aridity like condition, that is desert like condition is experienced over here. So if we see no Laurentian climate in southern hemisphere has very small landmass beyond 40° south latitude, and the only possible location in whole world was in Patagonia Desert. But Andes blocks westerlies from Pacific. Patagonia faces aridity, then continentality. So it faces aridity, desert-like condition. And annual rainfall is less than 25 cm. We see that the oceanic influence makes climate equable, that is, there are no extremities of temperature, that is, summers are moderate and winters are also little cooler. So here we do not see either effect of continentality nor eastern margin climate. So because of the Andes over here which blocks the winds coming from Pacific, it does not experience Laurentian climate. Now let's see the characteristics of Laurentian climate. We can see that these are the two regions in the world which experiences Laurentian climate. Here, the temperature can easily go below freezing point in the winters, and the winters are cold and dry. The rainfall is generally less. Here in New York, we can see that the rainfall is there, but in general, the rainfall would be on the lower side. Snowfall is also very normal because the temperature is below freezing point. We can see that in New York even the temperature does fall below 0 degrees Celsius. If you see the summers, they are warm and wet, and they are as warm as tropics. So the temperature in the summer season we can see it is higher than 25 or even 26. So the average temperature of the summer is approximately equivalent to the tropical climate. Now the summers could have been warmer, but their temperature is reduced by cooling effects of offshore cold currents. So here we know that there is this cold current which is flowing over here, thus it reduces the temperature of this region in the summers. This is Labrador current. Similarly, here also we have cold current near Japan and also in this sea over here. So because of these cold currents, the temperature of this region is reduced in the summer and it is more equable. Now if we see the Laurentian climate, then the precipitation is uniform throughout the year with summer maximum. So summer maximum is there and generally it has a very uniform rainfall. In winters the rainfall is however less compared to the summer. 2/3 of rainfall is in summer. Annual precipitation is from 75 to 150 centimeter. Winter is cold and dry. Dry westerlies blow from continental interiors. So the winds, they will blow from the continental interiors towards the oceans. Now let's see the specific characteristics of Laurentian climate in North American region. And now we will see the Laurentian climate in New York. So it has uniform precipitation throughout the year. So this region in North America, it has uniform precipitation which we can see. 7 to 10 centimeter of rainfall occurs each month and annual precipitation is around 100 centimeter. So we can see that there is rainfall in almost each month. Late summer maximum, June, July, August are the most rainfall giving months. So here we can see that this is June, July and August, and in this months generally the rainfall is highest. Now let's try to understand why the Laurentian climate in North America experiences uniform precipitation. That is, the rainfall is equally distributed throughout the year. And here we can see this is the Laurentian climate in North America. And here we have Great Lakes. And also we have Atlantic Ocean over here, which is very close or almost adjacent to the Laurentian climate. So it is because of the experiences of these Great Lakes and the Atlantic Ocean which provides the moisture, we get rainfall throughout the year. Second is warm Gulf current. So we see that on the coast of North America, on the eastern side, we have this Gulf Stream which is warm ocean current. Now these warm waters, they produce a lot of moisture. The winds which move over this Gulf Stream and reach over here, they carry the moisture from here and bring it to this region. Therefore, they give a lot of rainfall. That is, warm Gulf Stream increases moisture content of easterlies winds from Atlantic. Westerlies penetrate across Rockies. They carry depressions over Great Lakes and New England states. Westerlies bring rain in winters and it is good for agriculture in Northeast North America. So what happens that if we see over here, then you can see that the winds, they will bring depressions from here, and we can see that there is this low pressure like depression in this region over the Great Lakes. So the winds, they will flow from here, they will carry the moisture from the Great Lakes and then they will give rainfall in this region. So this is how the westerlies in winter specifically, they will bring rainfall to this region, which is very good for agriculture. Again, the fourth is warm Gulf Stream and cold Labrador current, they meet over here. So we can see this is the Labrador current which is coming from the Arctic Ocean. This is the Gulf Stream which is coming from the tropics. So both of them meet over here around the Newfoundland. Now because they meet over here, they produce a lot of mist and fog. Moreover, these currents, they carry a lot of phytoplanktons over here, providing very rich breeding grounds for fish. So because these two currents, they meet on the coast of Newfoundland, they produce mist and dense fog. So this mist and dense fog, when they reach over the land, they sometimes give rainfall. So it is because of these four regions we will get annual rainfall which is equally distributed. So it is because of these four regions we will see that the Laurentian climate of North America experiences uniform precipitation throughout all the months. Now let's see about the temperature in North American region. So westerlies bring less depression in summers. We have seen in the previous slides that in the winter months the westerlies would bring depressions from the Rockies mountain towards the Great Lakes, and then they will give rainfall, so they will calm down the temperature. But here in summer the depressions are less. Continental influence extend till coast. So the continental influence, that is the extremities of temperature, they can be experienced till the very coast, so it is expanded in the summer. Temperature is normally high for this latitude. You can see that New York is 25 to 32 degrees Celsius, which is equivalent to the tropical temperature. Moisture also remains high because it is very close to the oceans. Prolonged heat waves are experienced in the summer months in this region. And if you talk about winter, then the temperature drops and snow falls. New York has 2 months below freezing point. So if we see this graph, we can clearly see that these 2 months, that is January and February, the average temperature falls below 0 degrees Celsius. Interior regions have even more harsh winter. So if we go away from the coastal areas, then we will see that even the harsher conditions are experienced there. Temperature range is very high. So if we see the maximum temperature, maximum average monthly temperature and minimum monthly average temperature, we can see that the range is very high. Here we can have -5 and here we can have 25 degrees Celsius approximately. So we can see that the range is around 30 degrees Celsius, which is very high. Now let's see the Laurentian climate of Asian region, where we will start with the precipitation in Asian region. We see in winters cold and very dry wind will flow. Here we can see that there is no rainfall in the winter months, and therefore the wind is very dry. Summers are very warm and wet. So we can clearly see that the temperature is very high in the summer and there is abundant amount of rainfall in this. In fact, the rainfall is concentrated in the summer months. Rainfall is less uniform than North American Laurentian region. So we saw in New York that the rainfall was equally distributed. We also saw the reasons why the rainfall was equally distributed in New York. But here the rainfall is concentrated in the 4 months. So most rainfall is concentrated in 4 months, like tropical monsoon in India. So in India also the rainfall is concentrated in the 4 months. Therefore it is called cool temperate monsoon climate. So because of this similarity, where the rainfall is concentrated in only few months, it is also called cool temperate monsoon climate. Cool temperate because it is located in the cool temperate zone. Now the rain here is brought from southeast monsoons. That is, the winds which are bringing this rainfall, they are coming from the southeastern direction. In India it was coming from southwestern direction. And because here the winds are coming from southeastern direction, it is called southeast monsoon. Here we can see the movement of the winds during the summer of the Asiatic regions. Here we can clearly see that the winds are moving from the Pacific towards the inland or towards the Asiatic continent. This region is the region having Laurentian type of climate. So we can clearly see that the winds in summer are moving from the Pacific towards the land. So they will carry the moisture from this region and then they will give rainfall to all this region. That is why we saw that here the rainfall was concentrated in the months where the winds were blowing from ocean towards the land. Now if we see the precipitation mechanism, then we can see that in the summer the mountainous interiors of China are heated, and because of this intense heating, a low pressure region is created over this China, while the oceans, they are relatively cooler, therefore high pressure is over there. Therefore the winds, because of the pressure difference, they will move from here towards the land, carrying the moisture, giving the rain, and hence it is called southeast monsoon. Remember, this is the southeastern direction. In India it was southwestern direction. Now let's see the wind movements in winter months. Again, this is the Laurentian region, and now we can see that the wind is moving from the continental interiors towards these oceans. We can also see the pattern of wind movement over Japan, where we can see that the winds are moving from the continents towards this ocean or towards this sea and then crossing the Japanese island. We will discuss Japan a little later, but if we focus over here, we can clearly see that the winds are originating from interior and then they are moving towards the Pacific. So the winds which are originating over here, they will be very cold. We can see the blue color indicates cold region. So here we can see that the dry cold winds blow out of the continent. Here we can see it is the dry cold winds. Now we know that if we see this map of China, then here we have Gobi Desert and other deserts. So the winds which are blowing from this region, they will carry the sand from the region and it will be deposited over this region, forming a specific type of sedimentary plateau which is called Loess Plateau. So the wind carries fine yellowish dust from deserts of Central Asia, which includes Gobi, Taklamakan, and then there is other deserts over here. Then the dust is deposited creating Loess Plateau in Shanxi, Shenxi and other regions on the band of Huanghe River. So this blue color indicates the Huanghe River and the deposition of the sand particles over here. It creates this CLP, Chinese Loess Plateau. Much of the winter precipitation occurs as snow. So the winds which are originating in the interior of the continents over here, they do not carry much moisture. But whatever moisture they carry, they will give snowfall rather than rainfall. We have already seen in the previous slide that the precipitation in the winter is very less. Even the smaller amount of rainfall or precipitation that occurs, it occurs in the form of snowfall. Here we can see that the precipitation is almost negligible in the winter months, but this precipitation will be in the form of snow. Here is the summary which we have already discussed. In summer, mountainous interior of China heated, creating low pressure region. Winds will blow from Pacific and Japanese Sea because of the difference in pressure, and therefore we have southeast monsoon type of climate where rainfall is concentrated in 4 months. In winter, dry cold winds blow out of the continent. They carry yellowish dust. They are deposited in the Huanghe band, creating a Loess Plateau. And much of the winter precipitation occurs as snow. So we have already discussed this. Now let's see the precipitation characteristics of Japan, which is very much different than those of China or North America. Here we can see that the rainfall is distributed across all the months, but there is wide difference between the average rainfall in these months. There is clear peak, there is clear two peaks in Japanese precipitation. Here we can see that one peak is over here in the summer and then another is in the starting of the winter. The Japan climate is modified by insularity, that is it being an island. So the characteristics are modified. Here we also see warm Kuroshio current meets cold Oyashio current. So this is the Kuroshio current which is warm and this is the Oyashio current which is cold. Both of them meet over here and they produce fog and mist. So in this region fog and mist is produced and it produces the Japan into a second Newfoundland. So because of these characteristics, Japan is also like Newfoundland where there is very good grounds for fishing. Conditions are favorable for fishing. Fishing is more important than agriculture in Japan. Now if you see the precipitation of Japan, then we know that in summer the wind will blow from Pacific Ocean towards the land. Therefore, the winds which are passing over the Japanese island, they will give rainfall over here. And that is why we saw there was a peak in the summer for Japan precipitation. In winter, northwest monsoon, the winds will blow from northwestern directions as we can see over here. Now these winds which are blowing from the land towards the Pacific, they will cross this ocean, this Japan Sea over here. And after crossing the Sea of Japan, they will give rainfall in this region. And therefore we will have second peak. So in winter, northwest monsoon, this is the northwestern direction. Northwest monsoon is dry cold but blows from Asia's inland. After crossing Japan Sea, it will gain moisture and give rainfall and snow to Japan. So that is why we have two peaks in Japanese climate. Rainfall is evenly distributed and there are two rainfall peaks. First is June, which is called plum rain, and second is September, October, which is called typhoon rain. So here, in fact, in September and October, we also experiences typhoon. So because of that also, there is rainfall in Japan in these months. Now let's see the natural vegetation in the Laurentian type of climate. So cool temperate forest is key vegetation. Cool temperate forest means forest having the coniferous type of trees. tree growth is favored by heavy rainfall. We have seen that almost all of the Laurentian climate they had heavy rainfall, warm summer and damp air from fogs. We saw here we have the Labrador current and the Gulf Stream meeting. Here we have Kuroshio and Oyashio current meeting. So because of that there was damp air from fog. Summer is also warm and rainfall is also heavy. So because of these three conditions, there is very good condition for growth of trees over here. Winter is lengthy and severe and therefore it checks the growth of forest. And the trees which are not adaptable to cold, they cannot survive during the winter. Coniferous forest here are extension of taiga forest in Siberia. So we know that across these regions in the Siberian type of climate, we have coniferous trees. And those trees specifically in Siberia are called taiga forests. So here also they are an extension. We can see that these forests they extend in the Laurentian climate also. And because we have coniferous trees, lumbering is a key activity over here. Bank of St. Lawrence of Canada is basically known for timber and wood pulp industry. Now, if we see the Laurentian climate, then there are different types of vegetation of forests over here. If you are going below 50° north, then the coniferous tree is replaced by deciduous trees. And here we have main species of oak, beech, maple and birch. Deciduous trees are fairly open. Fairly open means that there is not very large undergrowth between the trees. Deciduous forests have undergrowth. So they do have undergrowth, but it is less compared to the evergreen forest, where we can see that lots of different types of trees or ferns they grow together. So here there is some distance between the trees, but they do have undergrowth. Adequate supply of moisture due to maritime effect. So because of the oceans nearby, we saw that there was rainfall, so it gets a good adequate amount of moisture. That is why we see the undergrowth. Deciduous trees also occur in pure stand. Pure stand means that single species trees can be seen in an area. Now Asian trees are cleared for agriculture, while Canada, the more focus remains on coniferous softwood. Therefore, deciduous trees are not generally lumbered over there or cut down over there. Now let's see the economic activities in this region. So the most important activity of Laurentian climate is fishing. Then we have lumbering, timber, paper pulp, and these industries are important. So fishing is the most important, followed by lumbering. Then we have agriculture, which is very less important due to long and severe winter. Potatoes do survive over here, and in large areas of podzolized soil, that is laterite soil, we will see growth of potatoes. Oats and barley are also harvested before winter. In Asia, we see soybean cultivation in North China and Manchuria and Korea. In American region, most of the focus is on dairy farming and hay cultivation, and fruit cultivation is also done in some areas of Nova Scotia, which is known for apples. So we can see that agricultural activities do occur, but they are restricted to some specific crops which are inhabited or adapted to that region, specifically potatoes, which are adapted to cold climate. Now let's see the conditions for fishing in the Laurentian climate. So these regions, they have large fish population. Why? Because abundance of phytoplanktons, which are foods by fish. The phytoplanktons, they are brought down by the Labrador current, because the phytoplanktons are found in very high quantity in the polar waters. So these currents, they bring down the phytoplanktons, and here we see this is the continental shelf. That is, this region has very big continental shelf where the sun rays can reach the regions of the sea, the depth of the sea. Therefore, phytoplanktons, they survive in this region because they require light for photosynthesis. The slopes of the continental shelf over here, they provide the lights. Therefore, we see large number of phytoplankton surviving over here. Therefore, there is large quantity of fish because the fishes, they will eat the phytoplanktons. Therefore, abundant fish is available in this region, and therefore fish industry is very good in Newfoundland as well as in Japan, because even in Japan we see that the Oyashio current, which was the cold current, it met the Kuroshio current. Continental shelves slopes gently, stretches for large distance. So we can see that these are the continental shelves in the light blue color, and they are very gentle. These are the grand banks which are known for fishing. Meeting of warm and cool ocean current. Cold Labrador current meets Gulf Stream. Phytoplanktons are brought by cold currents. We have already discussed that phytoplanktons are brought by the Labrador current, which increases the population of phytoplanktons in this region, and therefore we have large amount of fishery in this region. So as we have seen, the Grand Banks of Newfoundland provide suitable conditions, and therefore fish of all types are found over here. Therefore fishery is a very good industry, and fishing is a major export of Newfoundland. Main fish is cod fish, and it is also the major export. Both pelagic, that is deep sea surface living fishes, as well as the fishes living in deep waters near the ground, both of them are fished over here. Modern trawlers are used over here like this, which drag these nets along the ocean to catch the fish. Fish processing industries are well developed in this region. St. John's is the chief port of Newfoundland, which is known for fishery. Now let's try to understand why fishing is a very important activity in Japan. So let's see the push conditions, or the conditions which make people to go towards fishery. The first is 80% Japan land is not suitable for agriculture. If we see this image over here, where we can see that most of it is mountains, therefore there is very less region where agriculture could be done. Mountainous regions of Japan and low agriculture possibilities. So because of these mountainous regions, there is very low agriculture possibilities in this region. Therefore, people do not have good income or food source. Lack of lowlands and pastures. Even this region does not have pastures. Therefore, animal rearing on large scale is not possible, and there is lack of meat supply. Now, if we see the pull factors, that is benefits of people doing fishing. So we see that the continental shelves around the Japan is very large, just like the Newfoundland, and therefore we see that it is rich in phytoplanktons, which is fish food, and because of that there is very large population of fish over here. Indented coastlines. We can see that the coastlines are not straight, but they have lots of indents. So here there is very good sheltered fishing ports, and the water is also calm over here. Therefore fishing is possible even in small boats. Warm Kuroshio current meets cold Oyashio current. Excellent breeding ground. So as we have seen in the Newfoundland case, here Kuroshio current meets Oyashio current over here, and phytoplanktons are brought down by Oyashio current, and there is very good conditions of fishing in this region. Then the Japanese people have been fishing for centuries, and technological evolvement has helped them advance boats and fishing techniques. They also have religious value for fish and fishing. Fish wastes, seaweeds are used as fertilizers. Even the waste of fish is also used as fertilizer in the agriculture which is done over there. And then technological advancement. The Japanese fishing industry is one of the most advanced fishing industry. There are boats where the whole fish processing industry is located on the ship. That is, the fish are caught by the smaller ship, they are brought on this ship, they are processed and directly sent to the market from this ship. It saves time and provides very fresh fishes. Even whaling is done. Whale hunting is also an important part of Japanese fishing industry. Another modern activity that is carried out in Japan is seaweed cultivation. Here we can see that seaweed is cultivated both for consumption as well as medical purpose. Pearl cultivation is also done, which is used for making ornaments. It also has some medicinal values. So both of these are also very advanced type of farming done in the Japanese fishing industry. With this, we will conclude our video on the Laurentian type of climate. I hope you have liked this video. If you have liked this video, then do share it with your friends. We have covered all the climatic conditions of the G.C. Leong book, so do watch all the videos. Thanks for watching the video, and if you like what we are doing, then you can use the Paytm ID. Thanks for watching the video.